All right, we're back. I think I have found a little solution to the mouse, at least a temporary one. Okay. Okay. It's all right. All is well. All right. So I just showed you that of so similarly, everything is actually similar to whatever kind of staircase you want to achieve. Okay, using Protadetail. Okay, so supported at outer spherical, supported at inner spherical. You can see this is actually for the spiral kind of staircase. So you can see here what we have. Story height 3 meters. I believe you understand that already, where that is coming from. Okay. I think I should have a spiral kind of staircase here, if I'm not mistaken. And then for the straight flight I was explaining the other time, my mouse actually had some little issues. Okay, so so you can see how a typical example of a straight flight kind of staircase is. Okay, so it's just a flight straight, as the name actually implies. Okay, so you can see the landing. Sorry, I don't know if you are seeing my screen right now. Let me switch here to here. Okay, so I believe you should be seeing my screen right now. Okay, so you can see how the straight flies actually looks like. This is the plan view for the straight flight kind of staircase. You can see it's supported at by the side. Okay, so you can see the support is by the side here. So sometimes you get it from the software where it's telling you or asking you, is the support by the side or by the edge? Okay, so this one you can see the support is by the left hand side of the staircase. Okay, so this is a typical example of a straight flight. Let me see if I have a helical kind of staircase here. Do I have helical? I'm supposed to have, sorry, not a helical, spiral, right? Spiral, spiral, spiral. I'm supposed to have a spiral staircase here. Sorry, I have to. Good, I have one here. So you can see how a spiral kind of staircase is. Okay. So you can see how the plan view is. This is the plan. So if you cut this section here at B, this is cross section BB. This is what you're actually going to have. I believe you're familiar with this. When you view it from the plan view, okay, let's assuming you are at a higher story kind of building. If you are looking at this from that view, you are actually going to see the staircase in this way. Okay, and then when you cut this at a section like this, this is definitely what you're going to see. You're going to see it this way. Okay, I believe you must have seen something like this before. Okay. Okay, if that is correct. So this is a typical example of a spiral staircase. You can see I have another one here. So this is a typical example of how a spiral kind of staircase is. Okay, so if you cut this at, okay, you cut this here at CC, you can see what you have. This is C, you know, you have like a column here that stands as the support, okay, that is holding all of this, your landing that you have. Okay, so this is how it actually looks like. So let me take you back to Protadetail. Let me share my screen, share to Protadetail. So I'm here. All right. Now you can see what I have here. You can count the number of steps. Here is 17 based on what is here. You can change that value based on whatever you have from the architectural drawing that was actually given to you. And then the step width, okay, is 300 based on what I have here. You can actually change all of that as well. Let's say I have this to be 150. I always so, but this information, you definitely get that from the architectural drawing. Okay. Stairs width, there you can increase, specify the width of the stairs. You can see from the drawing here, what we have here, you can see it's telling us that from here to here is the width of that staircase, okay, which is at 1,500. So make sure whatever you are specifying will actually be in accordance to whatever the architectural drawing is giving you. So you are not just to assume information, okay? It's based on whatever you have from the architectural drawing. So that is the information you are actually going to type in here, okay? The average radius, 2,250. So let's change this radius. You are going to see is going to increase in the cycle or it will reduce in the cycle. So let's say the radius is 1,000, or let's say the radius is 3. Let's have it this way. So you can see it has actually, it reduces, okay? Let's say I have it to be 1,200. So this radius is not a radius that you are assuming. You are not assuming any value, okay? It's based on whatever you are getting from the architectural drawing. Okay, let me do something quickly here and take you back to the AutoCAD drawing that I have here. I don't know if this radius was specified. Let's see. The archi drawing is not here, but I believe you understand what a radius means, okay? If you want to know the radius of a particular cycle, if you take a cycle this way, you take a line, let's look for, this is the center here. So if I take the measurement of this right now, it's going to tell me the radius of the cycle is 5,400. Okay, so let's say I want to know, that means the diameter of this cycle is going to be 5,400 plus 5,400. Okay, so let's do that now and check the entire diameter of this cycle. You are going to discover 10,800. If okay, I think there's a little mixed up somewhere. So it's supposed to be 10,000. I think I'm not picking it at the right point. It's supposed to be exactly 10,800. Okay, that means this my radius, I'm not getting it right. Okay, it must have done a little approximation for us there. So the radius of the cycle is actually the center of that. If you take the diameter of a cycle divided by 2, that is actually going to be the radius of that cycle. So let's say I want to take a cycle and I type in cycle. All I need to do is just to specify the radius. It's telling me specify center point. I specified here, and then I'm going to specify the radius to be 5,400. So if you measure this cycle and this one, you discover that it's actually the same with this. So this cycle and this cycle are the same size of cycle. Okay. So the same thing implies here when you are coming up with your spiral kind of staircase. So whatever you are using for this staircase information is based on what the architect must have specified in the architectural drawing. Okay, so I'm going to assume that this is actually what I was given by the architect from the architectural drawing. I just want to assume it's like this. Okay, then I'll click on redesign. So you can see the lateral steel of stairs here is giving me like a red indication here. Let me change this to Y16 and see. Okay. Back, redesign this. Yes. Okay. All right. Let me increase this. Plate thickness here 150. Okay. Quantity. Okay. Lateral steel of stairs here. Just exactly what we did last time. You can also come here to select your reinforcement, or if you have the reinforcement already that you want to that is already existing and you want to actually just continue with the sizes of reinforcement and the spacing of those reinforcements. Sorry, my mouse is actually giving me some little headache right now. Okay. So I'll click on OK. Then, okay, you can see it has actually gone off. I'll click on design report. This is my report. So you can convert to PDF to Office, whatever format you think is better for you, and you can as well print directly from there. So this is my report. Okay, so the same way, just like you did for the other types of staircase, is the same way you can repeat similarly. Okay, so there's no much difference. The other thing is in sometimes so you have to follow whatever that is actually given to you by the architects from the architectural drawing. Some of these informations are already specified. So all you need to do is just type in these informations here and then redesigned it, and then design it rather. So once you design that, but there are informations here that you are not going to get from the architect, like the thickness of that plate. You as the engineer, it is your responsibility to provide the thickness of the plate that can be able to carry that staircase. Okay, and then the sizes of the reinforcement, the spacing of the reinforcement, and all that boils down to your analysis and the design that you're actually going to do. And the software is there to actually help you come up with all of that. Okay, so all you need to do is just type in these informations, and then the software will do the magic for you. Okay, so that is that about staircase. So let me try to zoom this. Right. My mouse is really misbehaving right now. Okay. Mouse is actually misbehaving. Okay. So let me see here what I have. Retrofit wall, scaffold, cover, pad footing. Okay, so there is nothing much about staircase more than what we have done already. Okay, so all you need to do is you need to understand staircase detailing, if possible, the manual way to come up with your staircase detailing in order for you to be able to interpret the detailed drawing is going to actually provide for you. Okay, um very important. That is why the knowledge of AutoCAD honestly cannot be overemphasized. It can help you to actually come up with your manual drafting, okay, and annotation. It can actually, so you can use that software to come up with all of that, okay, just in case you may want to add some details to whatever detailed drawing that the software is actually giving you. Okay, let's go down to now to our okay, let's come now to our retaining wall. You can see what we have here as your retaining wall. You can see the wall height, the casting height, the wall length, the stem to width, eccentricity from left, base plate front length, stem bottom width, base plate back length. So this is actually what we are going to be doing on the next episode. Okay, but quickly let me show you. You can see the height of this wall based on what we have here is 5 meters. You have to specify based on what you have seen, based on the condition of that particular site, to specify the particular height. Okay, so you must have visited that particular site and have put down all of your reports. So you must have taken note of the height of that particular site in order for you to specify in whatever you want to actually retain. Okay, it's a cantilever retaining wall, like I said. So it depends on whatever. Hello, are you there? It can cease by itself.